So today we are going to start the lesson coplanarity of three vectors. Now first thing, what do you mean by coplanarity? First, it has we have heard of collinear, right? Collinear means what? Co means what? Same. Points lying on the same line is known as collinear points, right? So coplanarity of three vectors means what? All the three vectors should lie on the same plane. Suppose we have a plane like this. This is a plane, right? So coplanarity of three vectors means, so suppose I have A vector in here, then B vector in here, then C vector in here. So it means that all the three vectors lie on the same plane. It can be XY plane, it can be YZ plane, or it can be ZX plane, right? Now let's move on to some way back to our chapter number 4. In that chapter we learned a formula, right? That area of a triangle. How did we find the area of a triangle? What was the area of a triangle? Achha, one thing, what was the name of the chapter I'm talking about? It's determinant. So area of the triangle, what was the formula? Is equal to half. We have 1, 1, 1, x1, y1, x2, y2, then x3, y3, right? This was the formula where x1, y1, x2, y2 and x3, y3 are the 3 points. Suppose here we have x1, y1, then we have x2, y2, then we have x3, y3. These 3 points make up a triangle, and this formula gives you that area of the triangle. Now my question is, in that portion you have learned one expression, that if these 3 points lie on a same line, suppose these 3 points are collinear. Now what's happened with the area? Suppose I have a line and these 3 points lie on this line, okay? So can you tell me what is the area of the triangle formed by these 3 points? Can you form a triangle? No. So the area of the triangle will be 0. Am I clear? Understood? So for 3 collinear points, the area of a triangle is equal to 0, right? So I think we have proved also like this type of things in our chapter number 4. Now the same concept we will apply in here. In our previous lesson in scalar triple product, what we have learned? We learned to find out the volume of a parallelepiped, right? Now parallelepiped was formed by what? Suppose we have a plane like this. B and C lies in here, right? Now we do the cross product of B and C, we get a perpendicular vector, that is what? B cross C, right? Now we had another vector, that is A vector, right? So we drawn a parallelepiped like this. Now if I have 3 vectors A, B, C all lying on the same plane, can we draw a parallelepiped just like before? Can we do that? Yes or no? No, right? So in the previous one, what was the volume of a parallelepiped? Volume of parallelepiped was equal to how much? It was A, B. You can use the comma or you can't, that doesn't matter. So this was our volume, right? The modular sign, because we will take the positive value, right? So this one was our, okay, let's write it like this: A dot B cross C. This one was our volume of parallelepiped. Now when the 3 vectors are lying on the same line, can you tell me what will be the volume of the parallelepiped? There will be no parallelepiped, right, for the first case. So the volume of parallelepiped, volume of parallelepiped for 3 coplanar vectors is equal to 0. Very, very important thing. So volume of a parallelepiped for 3 coplanar vectors is equal to 0. So if they ask you, they have given 3 vectors and they ask you to show that whether they are coplanar or not. So what expression should I use? We use that A dot B cross C equal to 0. If we prove this one, then we can say that three vectors A, B and C are coplanar. Clear? Understood? So that's how we prove coplanarity of three vectors. Okay? Okay, there is another way to explain this thing. Look at here. We have drawn a plane, right? Where A, B, C lies on the same plane. So now look at here. First, for the moment, forget about A. Let us see B and C. Now B and C are lying on the plane. So next step, what I do? I'll draw a perpendicular because I drew B cross C, right? So we get B cross C. Understood? Now what I have to do? Now I have to do the dot product of A and B cross C, right? Now anybody, can you tell me the dot product of A and B cross C is how much? Look at here. This is equal to what? A, B cross C, cos theta, right? And what is the angle between this perpendicular line and this plane in which A is lying? It's 90 degree. And cos 90 is 0. So this one is 0. Understood? There is another way to explain this thing. Clear? So that's how we can say when three vectors are coplanar, their scalar triple product is equal to 0.